Before we get started, we need to define our term. Current. Current is the flow of electrical charge through a point in a given amount of time. Or in terms of our 9-volt battery, which has a positive and negative end, it will send the negative electrons away from the negative end, through the circuit, through the light bulb, and then back to the positive end. Those electrons are flowing through the circuit. As they do that, they'll go through a specific point, and I could have chosen any point. I could have chosen here, 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 or even the light bulb if you so choose. And as the electrons pass through that area, they are flowing just like a river. And in terms of a river current, it's the exact same thing. The current is the flow. Now, the unit for current is amperes, or simply amps, which is defined as 1 coulomb of charge per 1 second. You might be asking yourself, why do we not count electrons per second? Because that's essentially what's actually going on. The reason is there's so many electrons per second moving that it would be ridiculously difficult to count. So now we can look at the actual values of what a coulomb is. 1 coulomb is the equivalent to 6.24 times 10 to the 18th electrons. Or rather, 1 electron is equal to 1.6 times 10 to the negative 19th coulombs. Another thing to keep in mind that an electron and a proton have the exact same charge. The only difference is electrons are negative, protons are positive. However, since we're looking at the flow of charge, we need to first examine what an atom looks like. You have the protons and neutrons located in the nucleus, and the electrons orbit around that nucleus. Knowing this, you need to realize that the protons are locked into the nucleus and never move in the flow of charge. The only thing that moves is the electron goes from one atom to the next, to the next, to the next. So the same is true when we look at the electrons and protons in copper, or in this case, a copper wire. It's the exact same thing. The protons and neutrons never move, it's just that the electrons go from one direction to the next. Or rather, one location to the next. So the electrons are the only thing flowing through the circuit. Bringing this back to our original definition of current, 1 coulomb per second, or the amount of charge flowing through a point in a given amount of time. So our variable for current is I, which we can define as the total charge flowing in a given amount of time. And looking at our units again, that's coulombs per second when you break it down into the SI base units. This means that in any given second, if you have 1 amp of current flow, you have 1 coulomb, or 6.24 times 10 to the 18th electrons flowing through any cross-sectional area of that circuit in 1 second. Before we go any further, we need to discuss the direction of the flow through the circuit. As we discussed earlier, with a 9-volt battery, it creates a positive and negative charge, or rather a difference between the terminals that is equal to 9 volts of potential energy on electrons. And throughout the circuit, we have a bunch of electrons in both sides. The first thing we're going to discuss is electron flow. Since this side is more negative than the positive end of the terminal, the negative electrons are going to want to be pushed away from that negative terminal and towards the positive terminal of the battery. So it's pretty straightforward which way the electrons are flowing, away from the negative towards the positive. However, when Benjamin Franklin was first studying electricity, he made a random guess about which way the current was flowing, and he assumed that the current was flowing from positive to negative. All of the math continues to work when approaching circuits from this perspective. And because so much work had already been done examining circuits and how they worked, that this became the conventional standard when approaching the direction of current. So when we talk about conventional current, or if from now on, whenever we refer to current, we aren't talking about the direction that the electrons are flowing. We're talking about the direction of conventional current, or rather the reverse of the direction the electrons are moving, which is positive to negative. If it makes it easier, consider the following analogy. Jimmy and Veronica are standing next to each other. Jimmy has a surplus of electrons. He then hands his electrons over to Veronica. As he does this, she becomes more negative, or rather the electron flow goes from Jimmy to Veronica. And while he gives away his negative electrons, Jimmy becomes overwhelmingly positive. So the positivity is flowing from Veronica to Jimmy. This is your conventional current. So electron flow goes from Jimmy to Veronica, and the positivity or conventional current flows from Veronica to Jimmy. From here on out, we will be using the conventional current, or the fact that the current flows from positive to negative, and as it flows through your light bulb, it should cause it to light up. This concludes the discussion of current for now, and I hope to see you next time. Thanks a lot. Bye.